Hi guys, it's Mrs. Todd here, and I'm going to teach you about negative exponents today. The best way to understand that is to just jump in and start exploring. So we're going to look at some patterns, starting with when the bases are 2. See, we have the base of 2. So when we have 2 to the third power, that would expand as 2 times 2 times 2. Well, we know that 2 times 2 is 4, times 2 is 8. All right, then 2 to the second power. So what's happening there? We went down 1 power, didn't we? We subtracted 1 from the power. So when we look at that, 2 squared would be 2 times 2, which is 4. So now 2 to the first power, look at what's happening. We're going down again on a power. And well, 2 to the first is just 1, 2, which is equal to 2. So now let's explore. This chart keeps going just down 1 power. And let's figure out what's happening. Let's go to the third column right here. So if we follow these blue arrows, we go, okay, we're at 8. When it goes down, if I'm at 8, how do I get to 4? Well, 8, let me switch to pen. 8 divided by 2 is 4. And now, following the next one, if I'm at 4, how do I get to 2? It is 4 divided by 2 is 2. So to get to this next one, it must be, let's divide by 2. So 2 divided by 2 ends up equaling to 1. So now what we've proven is 2 to the 0th power has to be equal to 1. And it's because what does our exponent mean? It means we don't have any 2's in this case. So if there's no 2's, let's look at this, then what would be there? Well, it's a 1 because look at this. If we thought 1 times 2, and now there's no 2's, what do you just have? You have 1. Okay, so now let's continue this and go on down by extending that pattern and divide by 2. 1 divided by 2 is 1/2. Okay, 1/2 divided by 2, find the next one. 1/2 divided by 2 is 1/4. And now extend this one, and 1/4 divided by 2 ends up being 1/8. And what I want to draw your attention to is right here. That's a little dark, isn't it? Let me rewrite it. That 8, well, right here we had an 8. And let's look at those exponents. Here the exponent was 3. Here it's almost the same, it's just a -3. So that exponent of 3, whether it's negative or positive, still gives us a type of 8. So what's the difference? When it's negative, the 8 is in the denominator. So now I can come over here and use that to figure out the expansion. If the 8 is in the denominator, that also means the 2's had to be in the denominator. So what's on top? Just a 1. Okay, so let's do that for 2 to the negative first. So 1/4, all right, look at it, 4 and 4 here, they match up, so their exponents are both 2's. But when it's a negative, the 4 is in bottom instead of just the whole number 4. So that means the expansion of 2 times 2 also had to be in the denominator. And then again, look at this one, the 2. It matches up right here, and if you come over here, both of those had exponents of 1. It's just one of them is negative, so what's that negative obviously causing it to do? Causing that 2 to move to the denominator. So now I think we can kind of come up with what the rule is for when you have a base and you have a negative exponent, like -n. The negative just means all of our expansion, everything moves down to the denominator. Okay, so now let's use that idea to fill in this next chart, starting in the middle. So if I had 3 5's and then 2 5's, then 1 5, remember, when we have 0 5's, we have to have something to hold the placeholder, and in multiplication, that's a 1. Now the negative exponent of -1 means that the negative means it's going to be in the denominator. Now it's a 1, so that means I'm going to have 1 5 in the denominator. Okay. Now the next one, the negative means the 5's are going to be in the denominator, but I'm going to have 2 of them. So that's 1 over 5 times 5. And then finally, the negative means they're going to be in the denominator, and I'm going to have 3 of them. So that's 1 over 5 times 5. So now 5 to the 0th was 1. So that equals 1 here. This one would just be 1/5. This one would be 1 over 25. And this one would be 1 over 125. So now let's check my work. Both of them that have an exponent of 3 should have 125. They do. Both of them that had an exponent of 2 should have a 25 somewhere. They do. Both of them that have an exponent of 1 should just have that 5, and they do. And then this one ended up being 1 again. So hold on, let's look at that. The base of 2 raised to the 0th was 1, but now I'm saying the base of 5 raised to the 0th is 1. Does that make sense? Well, let's check. Let's check this pattern. 125 divided by 5 turns out to be 25. 25 divided by 5 turns out to be 5. And now 5 divided by 5, well, that's 1. So that confirms it. It's still 1. So now we have another rule that we've found. And that rule is this. It's for the power of 0. We say, oops, I didn't mean to do that. Let me erase that 5. Here's what we say. We say any base raised to the 0th power is equal to 1. It'll always be equal to 1 because when you look at this pattern, you'll have the number itself, the base, divided by itself. So right here, you will always get a 1. All right, so let's fill in some notes from studying the patterns. What's some things that we've come up with? Any base raised to the 0th power is always going to be equal to 1, no matter what the base is. It's just 1. All right, you can change a positive exponent to a negative exponent. But when you do so, the expression moves location in the fraction. Numerator to denominator or vice versa. Okay, here's why I was able to generate that rule. Do you remember when we had 2 to the 3rd and we compared it to 2 to the negative 3rd? See, the positive exponent changed to negative, but remember what happened was this one was 8 and this one became 1 over 8. So it moved location in the fraction. Okay, we could also look at it this way. If I had 1 over 2 to the negative 3rd, now what would happen is I could say that would be the vice versa part. I would move it up, and that would end up equaling the 8, because I would say it was equal to 2 to the 3rd, which was 8. Okay, because it's just about moving locations. All right, you can change a negative to a positive, which I just showed you. But when you do so, the expression moves locations in the fraction. Numerator to denominator or vice versa. So basically, to summarize these two, you can change the signs of that exponent, but when you do, just move the base and the exponent to the other location in the fraction. All right, so these can often have many different answers. So let's look at this. 8 to the 4th is the same thing as 8 times 8 times 8 times 8. Well, this 8 times 8 is 64. This 8 times 8 is 64. So wouldn't you agree that's the same thing as 64 times 64, which is the same thing as 64 to the 2nd power. So now what I've done is I've rewritten it in a different exponential form, and my exponent is not 1 or negative 1. All right, let's look at the second example. 1/9 is going to be written using an exponent that is not 1 or negative 1. Well, we know 9 is the same thing as 3 times 3, which is 3 squared. So I'm going to rewrite it as 1 over 3 squared. All right. And our second set of problems is write decimals in powers of 10. So here's how this works. First of all, a power of 10 is made up of a 1 with zeros behind it or a 1 with zeros in front of it. These are focused on the 1 with zeros in front of it. That ends up giving us a negative exponent when the zeros are in front. So I'm going to write my base as 10. That's what it means to be a power of 10, is write it as a base of 10. And to figure out how or what my exponent is going to be, I've got to count zeros. So there's 1, 2, 3, 0. So it's some sort of 3. And I already told you it'll be a negative 3. Notice I counted that beginning 0. Another way to look at this is how many times do you have to move this decimal to turn it to a whole number? The 1. You would have to move it 3 times. So therefore, it's a negative 3. All right, we're going to do this one as a power of 10. So write your base of 10. And let's look at it both ways. We can count zeros and go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that would be to the negative 10th. Or we could think about moving the decimal until it becomes the whole number of 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Either way, we end up getting a 10. All right, I'd like you to pause and try A through C on the try these. All right, let's look at the answers. Write 9 to the negative second as an expression with a positive exponent. Well, that would be 1 over 9 to the second. You got to move locations when you change the sign. Write 1 over 5 to the sixth in exponential form with an exponent that is not 1 or negative 1. Well, this satisfies the rule. Negative 6 is not 1 or negative 1. But let's look at another way. 1 over 5 to the sixth. Well, 5 to the 6 is the same thing as 1 over 5 times 5 times 5 times 5 times 5 times 5, right? This 5 times 5 is 25. This one's 25. So this one's 25. So that ends up the same thing as 1 over 25 to the third. So there's, like I said, a lot of different ways to answer those. And then finally on C, you end up getting 10 to the negative sixth. All right, you're ready to look at your practice on ConnectEd? Good luck, and don't forget to submit your screenshot. Thank you.